Good morning, grade 11. This is Mrs. Pascale. Today's lesson is Polynomials, Chapter 5, Section 5.2. The objective of this section is to find the zeros of a polynomial. Correction of the homework. To find the zeros of the following polynomial, we need first to factorize each polynomial, then solve it to find the values of x. So in example 1, for f of x equal x cubed plus 4x squared minus 5x, we can take x in common. So we get x squared plus 4x minus 5. To find the zeros of f of x, we take the whole expression equal to 0. So x into x squared plus 4x minus 5 is equal to 0. Taking each product or each factor equal to 0, we get x equal to 0 or x squared plus 4x minus 5 equal to 0. It's a second degree equation. We can find its roots by using the calculator, by using the factorization, by using the discriminant delta, or by any of the previous method taken in chapter 4. So this is an equation where we can find the evident root, since the value of a is 1, the value of b is 4, and the value of c is -5. So a plus b plus c is equal to 0. We have x equal 1 and x equal c over a, which is -5. So finally, the polynomial of third degree admits 3 roots or 3 zeros, 0, -5, and 1. It's the same concept for the second polynomial defined by x cubed plus 8x squared plus 16x. Taking x in common, we get a second factor in the form of x squared plus 8x plus 16. To find the zeros of this polynomial, we should take the whole expression is equal to 0. Taking each factor equal to 0, so x is 0 or x squared plus 8x plus 16 is equal to 0. Again, this second degree equation, we can solve it either by factoring it or by using the discriminant. So by calculating delta, we get delta equal to 0. It's a double root. It's an equation admitting the same value for x. X is equal minus b over 2a, so x is equal to -2. For the third degree polynomial, the roots or the zeros are 0 and -2, since -2 is double root. For the third polynomial, x cubed minus 36x, taking x in common, we get x squared minus 36. To find the zeros, we need to take f of x equal to 0, so the whole expression is equal to 0. It's in the form, the second factor is in the form of x squared minus 36. It can be factorized using the remarkable identity a squared minus b squared. So we write x into x minus 6 into x plus 6 equal to 0. Taking each factor equal to 0, get x is 6, x is 0, x is 6, and or x is -6. So for this polynomial, we have 3 zeros, -6, 0, and 6. For the polynomial of number 4, f of x is equal x minus 4 squared. It's a second degree polynomial. It's given in the factorized form, so we can directly write f of x equal to 0 in order to find its roots. X minus 4 squared is equal to 0, so it's a double root or double factor expression. We can take x minus 4 equal to 0 and x is 4. So for this polynomial, we have 1, 0, which is x equal 4. In number 5, the polynomial is also given in the factorized form, 2x plus 3 into x minus 1 square. So we can directly take the whole expression equal to 0. Taking each factor equal to 0, we write 2x plus 3 equal to 0, or x minus 1 squared equal to 0. Solving each equation, to x equal negative 3, so x equal negative 3 over 2. And the second equation gives x equal 1 as double root. So for the third degree polynomial, we have two zeros, negative 3 over 2, or 1. In number 6, it's a polynomial of fourth degree. Taking x squared in common, since it's the least power between the variable. So x squared into x squared plus 3x minus 4. To find the zeros of this polynomial, we should take the whole expression equal to 0. So x squared is equal to 0, or x squared plus 3x minus 4 is equal to 0. The first equation gives x equal to 0 as a double root, and the second quadratic equation gives evident root since a plus b plus c is equal to 0. So x is 1, and the second root is negative 4 over 1. It means negative 4. So the three roots or zeros for this polynomial are negative 4, 0, and 1.